Welcome back to my channel, everybody. Street Tips here, part 2 of the Platinum Refining Series videos. And before we get to that, though, I'd like to introduce a separate video that I intend to make while this is processing out in my fume hood. This is a box of watches that Mrs. Street Tips has accumulated on her travels, during her travels. And what we're going to do is go through some of this in a separate video and take out some of these watches and package them up and offer them for sale on my eBay store. But for right now, let's get right to it. Part 2 of the Platinum Refining video. Here we go. All right, to start this process off, what I have back in the back there is an experiment that I did with some copper. I dissolved copper back here in nitric acid. Then I transferred it to a separate beaker and I cemented the copper on zinc. And then once I got that cemented copper on the zinc, I added sulfuric acid, and it's currently on there boiling. That's boiling sulfuric acid right there. Highly dangerous. This is something you don't want to try to do at home. But the reason I'm doing that is because if you remember, I cemented this black powder on zinc. Well, zinc is way high up in the reactivity series of metals, so it will cement out any metal below itself. Anything below zinc is going to come out of solution onto the zinc. So, if you remember back in part 1, I showed an analysis of this metal and it contained copper. I'm going to take this boiling sulfuric acid down off of the heat here and set it aside. Let me get this out of the way. And the reason I'm doing this is to remove any copper that might be in with our platinum group metals. You see that blue color we got there? That tells me that we have copper in solution. So that sulfuric acid dissolved the copper out of our cemented metal that I did the experiment with. Now, if we've got copper in here with our platinum group metals, it will be indistinguishable from the platinum group metals. It'll look just like the PGMs, a black powder. So before I go any further, what I'm going to do, this, by the way, is a rag that I used to wipe the inside of this beaker. It had some stuff on the inside of it there. I was concerned it may have some zinc chloride in there from the reaction that we did with zinc, so I wiped it all off on a paper, and I'll put this in with my paper storage. But for right now, what we're going to do is I'm going to add some concentrated sulfuric acid. This is Ruto Drain Cleaner. It is 93% concentrated sulfuric acid. We're just going to pour this right on into our mixed black PGMs here. I filled it up to about just below the 200 milliliter level. Okay, I'm going to drop in a stir bar. We're going to put it up on the heat now and let this stir and see if we can dissolve out any of the copper that might have ended up in with our platinum group metals. And we'll be able to tell when we turn this off and let this solution settle, and then look at it and see if we've got a blue color. And if it is, if it's blue, that means we got some copper to go into solution, and it will clean up our platinum group metals free of copper. We've had this on boiling now for 2 hours. And what I'm going to do now is, you can see there's a ring inside of there. Ring around the beaker. It's red. Red is the color of copper, and it's the color of rhodium. I've got some sulfuric acid here. What I'm going to do is I'm going to try to rinse down the inside of the beaker with a little bit of fresh sulfuric acid. carefully here. Oh boy, that looks angry. It's working. I'm getting the inside of the beaker rinsed out, or rinsed down, the sides of it there. But boy, oh boy, I do not like playing with boiling sulfuric acid. I'll tell you that right now. Alright, I think I got it all rinsed down. And I think it's been on here boiling long enough. So what we're going to do is pull it down off the heat now and let it cool. I'm just going to reach in here, pluck it off the stir plate here. We're just going to let this sit and cool down now. This has been allowed to cool to room temperature now. What I'm going to do is pour some distilled water into this beaker, and then I'm going to pour the acid solution off into the water and try to dilute it down. And let's see what we've got left in the bottom of this beaker. Here we go. Looks like platinum in solution, or some kind of metal in solution here. It's got a rose color to it. You see that? Just gonna pour this in real slow into this water now. Looks kind of red. This is room temperature. It's been allowed to cool to room temperature. And we've got some black powder left in the bottom of our beaker there, which is a good sign. All right. Ooh, we're starting to boil. See that starting to get real hot there as we pour off the sulfuric acid into the water. Gotta watch that or it'll spatter all over the place. Alright, I'm starting to pour some of the solids off now. Just gonna stop right there. Alright, that water heated almost to the boiling point. Got 203 Fahrenheit, 95.2 Celsius. All right, let me reach in here on this solution that we poured off, and I'm going to get a little bit of it on the end of a filter paper here. And can't quite tell what we got in solution here. Just a little bit on the end of the filtered paper. Put a drop of Stannous on here. It looks like we do have some platinum in solution. Do have a stain forming on that paper. Now it's green. It's turning green. That's an indication of platinum or palladium. See that green? Zoom in on it for you here. That is an indication that we have palladium in this solution, probably with the copper. All right, that test is palladium in solution here. Not a real high concentration. See that green stain on our piece of filtered paper here. So what I'm going to do now, don't squawk at me, this is the only way I can think of to get our remaining platinum metal in here. See that black powder left in there? That should be some fine-grained platinum. What I'm going to do is carefully, I know you're not supposed to add water to acid, but I'm going to carefully, this is the only way I can think to do it. You see it smoking in there as I do it. It turns to steam rather quickly. But as I get going here, it should. See it's steaming down there? That's just from the water hitting the acid and turning to steam. But as I go here, it should. This is why you don't want to add water to acid, because it turns to steam so fast it could spatter out acid on you. But once I get it diluted well enough, we shouldn't have to worry about that. What I want to do is get the rest of the sulfuric acid rinsed off of here. So what I'll do is let this settle then, and we'll add it to this beaker. And then what I'll probably end up doing, since it's not a very high concentration of palladium, is adding all this wastewater to my stock pot. I'm after the platinum that's down here. Alright, it looks like this is already starting to settle out. You can see it's clearing up with just a little bit of material suspended in that solution. Alright, here we go. We're going to pour a little bit more of this rinse water off now into this waste container. Try not to pour a whole bunch of the solids over as I do this. Like I said, this is probably going to be a weak solution of platinum, or palladium rather. So I'll just add it to my stock pot. Right now what I'm trying to do is get all the acid rinsed off of there. One quick last look at this Stannous test. As you can clearly see, it's green. That's a dead ringer test indication for palladium in solution. What this means is that boiling sulfuric acid will put palladium in solution. I've got the PGM black powder here rinsed. Most of the acid's been rinsed off. You can see I got a full beaker here of that rinse water. I don't know if I've got copper in here or not. I know I've got palladium. We did that Stannous test on that. But instead of adding this to my stock pot, what I think I'm going to do here is, if there is copper in here, what I can do is just pour it into this piece of copper in this large 2-liter beaker. And we'll see if we can get the PGM blacks to cement out on that piece of copper in there and recover it that way. If there's copper in this solution that I'm pouring off, it will not cement out on the copper, because copper won't cement copper. Only the platinum group metals will come out of solution, and that's what we want here. And you can see on the bottom of this beaker right here, a little bit of the black powder has accumulated and settled out. Now I'm going to pour this final rinse off of our mixed black PGM powders here into this 2-liter beaker with copper in it. See if we can get these metals to come out of solution on that piece of copper. And then we'll proceed to the next step. What I've got here in this beaker is our black mixed PGM powders. There's probably going to be platinum in here. And even though we got some of the palladium out, it's still going to be in here. There's probably iridium in here, as well as some base metals. Platinum group metals are very difficult to separate. All right, I'm going to do one more quick rinse of our black powder in here, and we'll let this settle out, and then I'll add it to this beaker. This is the procedure used for the black mixed PGM powders from the stock pot. I'm going to use it in this process. It says the washed black powder should be put in a beaker, cover it with a little nitric acid, dilute it with 2 volumes of water, and you'll see the reaction begin in a few seconds. The palladium and base metals will dissolve, and the platinum and iridium, any gold that might be present, will stay in the beaker. We don't want to do it too long. It says just do it for about a half hour with gentle heat. And so that's what we're going to do. I'm going to pour off this last rinse now. All right, I'm going to set this beaker in the back here out of the way. And what we'll do is I'm going to add a little bit of distilled water here, about 100 milliliters or so. Now I'll add in a splash of nitric acid here. This is 68 to 70% nitric. Just a little splash, probably about 10, maybe 15 milliliters. Stir it up. I'm going to put this up on the heat now. Put some low heat on and stir gently. It's about 5 minutes past 12 right now. I'm going to let this set on low heat with stirring, and we'll let this treatment go. What it should do is remove any remaining copper or palladium from our mixed black PGMs. The whole idea behind this weak nitric treatment is to remove any remaining palladium or copper. Here in a second you'll notice that I'm adding some additional nitric and turning the heat up just a little bit. There's no fumes being evolved, which tells me that I'm not putting anything in solution, and that's a good thing. That means there's no nitric or copper to go into solution here. We've been on the heat stirring for half an hour. Now we're going to pull this down off the heat, let it cool. Alright, I just took it off the heat, and if you look in here, you'll see that the solution is relatively clear and colorless, which tells me we didn't put a whole bunch of anything into solution. So I think our black powder is going to be very clean now for the next step. This has been allowed to cool to room temperature now. So what I'm going to do here is I'm going to add it to our jar back here and just let this nitric acid consume the copper and help cement any of the precious metals in this large beaker back here, help cement them out of that solution. I'm going to give this a rinse to see if we can get some of the nitric acid off of there. It's settling out pretty good. Alright, judging by the color of that liquid that I poured off earlier, we should have Very little, if any, copper in there, and very little, if any, palladium. Now what I'm going to do is I'm adding hydrochloric acid to this. About 150 milliliters. There's going to be some residual nitric acid in there that will start putting platinum in solution. So what we're going to do now is put this up on the stir plate, and we're going to start this stir plate up now. And add a little bit of heat to it. This is about 5 minutes after adding the hydrochloric acid, and the residual nitric in there is forming aqua regia and putting metal in solution. And my hope is that when all the excess nitric gets consumed by this reaction, those fumes will clear up, and then we'll go to hydrogen peroxide. Fume production has ceased. It's safe to conclude that most of that nitric has been used up now. So I'm dipping a piece of filter paper in here to get a Stannous test. As you can see by that test, we've got a dark orange stain for platinum in solution. Face shield, 3M P95 respirator, and long chemical gloves are my protection. Here I'm adding 3 milliliter doses of 12% hydrogen peroxide to the platinum group metals and hydrochloric acid mixture in the beaker there. In this next clip, I made the decision to start adding the hydrogen peroxide in a larger quantity. The 3 milliliter pipette doses were going too slow. So here you'll see me add this first dose. It flares up pretty good, but then it calms right back down. And then I'm able to get that entire 40 milliliter dose into the beaker. Here you'll notice that there's lots of bubbling as I add that 12% hydrogen peroxide, and that's due to the fact that there's lots of undissolved metal down in the bottom of that beaker. As the metal dissolves, this reaction will calm down when I add the hydrogen peroxide. This is the last of a 60 milliliter dose that I added in for a total of 100 milliliters now of 12% hydrogen peroxide. And notice how the reaction is docile. I think this is because the solution has cooled down significantly from adding that hydrogen peroxide. Here I'm getting another Stannous test. And the test is a much darker orange color, and at first it looks like it's orange only, but then as the Stannous reacts with the liquid on that filter paper there, it starts to turn a brown color underneath, and then I start seeing hints of green, which means we still have palladium, which is not surprising. Here I've measured out about 70 milliliters of 12% hydrogen peroxide, and I'm adding it right on into the reaction. I can tell by the amount of foam being produced there that I don't have very much solids left to dissolve in that beaker. If you remember, when I first started adding the hydrogen peroxide, I got a much bigger head of foam when I added smaller doses than I'm adding right here. And so I'm going to go ahead and add this entire 70 milliliters right on in this clip. You'll notice that the level in that beaker is up to about 300 milliliters. I need it down around 150 milliliters in order to precipitate the platinum out of that solution. So I'm going to have to evaporate some of that liquid off of there. This reaction has been on since 3 p.m. It's now 7:15 p.m. I've got it evaporated down to the correct level to get the right concentration in order to be able to precipitate the platinum. Now we'll just let it cool down and filter it. I've allowed that solution to cool down to room temperature. Now what we're going to do is we're going to filter out any solids that we might have in our solution. I'm going to wet the filter paper with a little hydrochloric acid. Keep it down into the funnel. And now here we go. We're going to go for filtration. Here, Three Tips is baffled at how fast that solution is going through the filter paper. And that is because the filter paper has failed. Well, that don't happen very often to have a filter paper fail like that. And I think it's because I used one of those brittle ashless filter papers. It caused the bottom to split apart. And here you'll see that there's a hole in the bottom of it. I decided to leave this in. I could have edited out, but I decided to leave it in just to show you how these mishaps do happen. I'll save that back there with the other filters. We'll put it in with our paper storage and recover the precious metals out of those filters later on. Here I'm going to rinse out the funnel with a little hydrochloric acid. I've got another filter set up, and we'll install that now. It's just a regular old Wattman fast flow #1 filter paper, and we'll continue the filter operation. The filter paper failing kind of befuddled me a little bit, and I forgot to turn the microphone on for these next few clips. It's just me pouring the solution through the filter to get it filtered out completely. Alright, let me capture the stir bar here with a magnet. You can see down in the filter here I've got some black powders being filtered out of the liquid. And you'll see once I get all this solution poured into the filter that there's going to be some black powder left down in the bottom of the beaker. Not quite sure what that is. There's not a whole bunch, but it's probably going to be some of the other platinum group metals. So I'm going to complete the rinse with hydrochloric acid out of this beaker. Try to get everything down into the filter. The filter will contain platinum group metals, so I want to save this filter with the other ones that I have, put it in my paper storage. See, in the filter there's quite a bit of black powder in here. Well, I say quite a bit, it's not really that much, but I'm going to rinse down the inside of the filter now with a little bit of hydrochloric acid. While I wait for everything to pull through the filter, I'm going to make some saturated ammonium chloride solution, and we're going to use ammonium chloride to precipitate out the pure platinum. What I mean by saturated solution is we're going to add ammonium chloride to this water until no more will dissolve. We'll be able to tell when that happens, when we've got a saturated solution, when we've got excess ammonium chloride on the bottom of our container. Got everything pulled through the filter now. So what we'll do is remove the filter and get it out of the way. Now I'll transfer our solution into this 600 milliliter beaker. Okay, here we go. The big moment that we've been waiting for. We're going to precipitate out our platinum. Here we go. I'm just going to pour this right in. See, we've got a saturated solution. We've got a little bit of undissolved ammonium chloride left on the bottom of my container. It's ice cold. That's a endothermic reaction. It gets real cold when you add it to the water. All right, let's see. Let me get positioned properly here. See if I can get close up with the camera. And we're going to go ahead and pour this in now, very carefully. Now, the platinum is coming out of solution there. But if there's any iridium or rhodium in there, or palladium, all of those metals will precipitate out with the ammonium chloride. Now, earlier we said that rhodium will not dissolve in aqua regia, nor will iridium. But there's going to be some rhodium and iridium in here. Because the metals are so similar that they tend to follow each other during these refining processes. Looks like a flesh-colored milkshake. Here I'm going to test with Stannous chloride, and you'll see I have platinum in solution. Unlike gold or silver, we just add more precipitant to get the rest of the gold or silver to come out of solution. But with platinum group metals, you can never get a 100% precipitation. Now the temptation here is to go after that additional platinum in solution with more ammonium chloride, but it won't work. That'll have to be added to my stock pot. Let's see if we can get our precipitate filtered out now. Just going to pour it right into this filter and collect up the precipitate. All right, I've got the last of it coming down into the funnel, into the filter there. And then we're going to have to go in and do some studying and figure out what to do next. I'm going to use a little bit of 15% ammonium chloride water to rinse the rest of the precipitate out of the beaker. Can't use water here because water will tend to redissolve this precipitate. Here is our filtered and rinsed precipitate ready for further processing. This will conclude part 2 of the platinum jewelry refining series. And I've got the precipitate out there. It's a flesh colored precipitate. I'm not quite sure how to proceed, but my plan is to use some formic acid here to reduce the precipitate to metallic platinum. And you can read the procedure if you have a copy of CM Hoke's book here. You can read the procedure that I'm going to use on page 158 of her book. And what else? That's it. That'll conclude part 2 of the platinum jewelry refining video. Thanks for watching.